Last episode, you learned exactly why classical machine learning hits a ceiling. The bottleneck was never the algorithm. It was handcrafting features by hand. Deep learning removes that ceiling by learning representations directly from raw data.
But here's what every tutorial skips. Before you can train a single neuron, you need a working environment. And the first time you try to set one up, it is remarkably easy to spend an entire day on driver conflicts, version mismatches, and CUDA errors. This episode fixes that. We cover every option, cloud, free GPU, and local setup, so that by the end you have a verified, working environment that runs every future episode in this series. I'm Mahaz. Let's build the environment. Today, TensorFlow versus PyTorch decision, 3 environment options, the exact pip install commands, your first tensor in both frameworks, and a GPU verification step you'll run every time you start a new project. The first decision, TensorFlow or PyTorch, which do you install? TensorFlow was created by Google in 2015. For several years, it was the industry standard, particularly for deploying models to production and to mobile devices through TensorFlow Lite. PyTorch was created by Meta in 2016. By 2019, it had taken over virtually all of academic research, and by 2022, most new industry projects were also starting in PyTorch, because it runs like ordinary Python and is far easier to debug. For this series, PyTorch is the primary tool. We use it for every model we build. TensorFlow appears where it's still dominant: mobile deployment, Keras high-level API, and a few specific production patterns.
The good news: the concepts are identical between both. A layer is a layer. A gradient is a gradient. Learning one deeply means you can read the other. We install both, but we think in PyTorch.
Option 1. Google Colab. This is the fastest way to get started with zero setup.
Go to colab.research.google.com. Sign in with any Google account. Click New Notebook. You have a Python environment with PyTorch and TensorFlow already installed, running in your browser. The key step: switching to a GPU runtime. Go to Runtime, then change runtime type, then select T4 GPU under Hardware Accelerator. That one change gives you a real NVIDIA GPU for free. Colab's free tier gives you roughly 4 to 6 hours of continuous GPU access before it recycles your session. For most episodes in this series, that is more than enough. One important habit: at the start of every Colab session, run the verification block from this episode to confirm the GPU is attached. Colab silently drops to CPU if you exceed your quota, and you won't notice unless you check.
Option 2. Kaggle Notebooks. More GPU hours per week than Colab's free tier.
Go to kaggle.com, create a free account, and open New Notebook. Under Accelerator in the right panel, select GPU T4 or P100. Kaggle gives you 30 GPU hours per week, more than twice Colab's free quota. Kaggle Notebooks persist between sessions, which Colab's free tier does not. Your code, outputs, and installed packages are saved, which is useful for longer training runs.
The trade-off: Kaggle Notebooks are slightly slower to start, and the interface is less polished than Colab. But for GPU-heavy episodes later in the series, CNNs, transformers, fine-tuning, the extra quota matters.
My recommendation: use Colab for quick experiments and following along with episodes. Switch to Kaggle for longer training jobs, or when you've hit Colab's daily limit.
Option 3. A local NVIDIA GPU. The most powerful option, and the one with the most setup steps.
First requirement: an NVIDIA GPU. AMD and Intel GPUs are not supported by PyTorch's standard CUDA build. If you have an NVIDIA card, even a gaming GPU like a 3060 or 4070, you're in a good position. Step 1. Install the NVIDIA driver from nvidia.com. Step 2. Install CUDA Toolkit. Version 12.1 or 12.4 works well with current PyTorch builds. Step 3. Install cuDNN, which accelerates the specific operations neural networks use most.
Then create a Python virtual environment, activate it, and install PyTorch with the CUDA flag. The exact command is on pytorch.org. Use their install selector to get the right pip command for your CUDA version.
Local GPU setup takes 30 to 60 minutes the first time. But once it works, you have unlimited compute with no session limits, and training is consistently faster than Colab because there's no network overhead.
Whether you're running locally or just want to follow along on Windows or Mac without a GPU, here are the exact commands.
First, create a virtual environment. In your terminal or command prompt, Python mvin-dlenv. Then activate it. On Windows, dlenv \scripts \activate. On Mac or Linux, source dlenv/bin/activate. Then install PyTorch. Visit pytorch.org, click the Install tab, select your OS, Python, and CUDA version, and copy the pip command it generates. For CPU only on any platform, select cuDNN. Install TensorFlow next, pip install TensorFlow. Then install the core scientific stack, pip install numpy matplotlib scikit-learn Jupyter. These 4 packages appear in every episode. For Jupyter Notebooks locally, pip install Notebook, then Jupyter Notebook to launch. All the episode notebooks in the series repository are designed to run in standard Jupyter or in Colab with identical results.
Now the most satisfying part, proving it works. Your first PyTorch tensor.
Open a notebook or Python file and type import torch. If that line runs without error, PyTorch is installed correctly. Then x equals torch.tensor of 2, 3, 4. Print x. You'll see tensor with those values and type float 32. Now something that will matter in literally every future episode. Print x.shape. You get torch.size of 3. Shape is how you understand what your data looks like inside a network. Every bug you fix later will start by checking shapes. Try x.2 of CUDA. If you have a GPU attached, that tensor now lives in GPU memory. If you get an error saying CUDA is not available, you're on a CPU. That's fine for now. We'll verify GPU separately. One more line that matters. Print torch.version. Note what it says. If you ever hit a compatibility error later in the series, your first step is always checking that your PyTorch version matches what the episode uses.
Same verification for TensorFlow.
Type import TensorFlow as TF. Then t equals tf.constant of 2, 3, 4. Print t. You'll see a TensorFlow eager tensor with shape 3 and type float 32. Check your version. Print tf.version. Also run print tf.config.list physical devices of GPU. If this returns a non-empty list, TensorFlow can see your GPU. If it returns empty brackets, it's running on CPU. One common confusion. TensorFlow and PyTorch tensors are different types. You cannot pass a TF tensor directly into a PyTorch operation or vice versa. Convert via number.py when you need to move between frameworks. T.numpy gives you a number.py array that both frameworks accept. For the rest of this series, PyTorch is the default. When TensorFlow appears, the episode will say so explicitly. If you only install one framework for now, install PyTorch.
The GPU verification block. Run this at the start of every session, not just this episode, but every project for the rest of your career.
Line 1. Import torch. Line 2. Print torch.cuda.is available. True means your GPU is visible to PyTorch. False means CPU only. Never assume. Always check. Line 3. If torch.cuda.is available, then print torch.cuda.get device name of 0. This prints your actual GPU model. On Colab, it will say Tesla T4. On a local machine, it prints your card. Line 4. Device equals torch.device of CUDA if torch.cuda.is available else CPU. Store this in a variable called device, then pass it to every tensor and every model you create. This single pattern makes your code run identically on GPU and CPU without changing anything else. You will see this device pattern in every single future episode. It is not boilerplate to skip. It is the correct way to write portable deep learning code.
Before you move to episode 4, run through this checklist. Every item on it protects you from a confusing error later.
Check 1. Import torch runs without error and torch.version prints a version string. Check 2. Import TensorFlow as TF runs and TF.version prints a version string. Check 3. Torch.cuda.is available returns true if you are on Colab with a GPU runtime, Kaggle with GPU, or a local NVIDIA machine. Check 4. A simple tensor creation, torch.ones of 3, 3, runs and prints the right shape. Check 5. Import numpy as np and import matplotlib.pyplot as plt both run without error. These two appear in almost every episode.
Check 6. The series repository cloned or downloaded to a location you can find.
6 checks. If all 6 pass, your environment is ready for everything from episode 4 through episode 72. If anyone fails, the GitHub README for this episode has the specific fix for each error message.
Recap. What you now have before episode 4.
PyTorch is the primary tool. TensorFlow is the secondary tool. Both installed. Concepts transfer between them. Frameworks are dialects of the same language. 3 environment options. Colab for quick work, Kaggle for longer training runs, local GPU for maximum speed, and no session limits. The device pattern, torch.device of CUDA or CPU, goes into every single future notebook. The GPU verification block runs at the start of every session. Your challenge: run the 3 verification lines, screenshot the output, and post it in the comments with which option you're using. Bonus: tell us your GPU model if you're local. An environment is not exciting. No one wakes up wanting to debug a CUDA driver. But without this episode, every future episode is 10 times harder.
You now have a working environment that runs anything from a single neuron to a full transformer. The rest of this series is about filling it.
Next episode: the math you actually need for deep learning. Tensors, shapes, matrix operations, and the dot product, explained visually and connected to code from the first minute.
Subscribe. Post your verification screenshot. See you in episode 4.